to solve some two-step linear equations with fractions or rational numbers, and we're going to try to do it in two different ways, so that way you can choose which way you like better, essentially. The answers will be the same, of course, and you'll get the correct result regardless of the way that you decide to do it, so just decide which way you like best. Our first approach would be standard compared to what we would do in an integer case, where we just had, for example, whole numbers or negative numbers with no fractions and no decimals. And that process would be to unwrap the present, try to get the y by itself, the variable. So because of the adding of 2/9, I'm going to subtract 2/9 from both sides of the equation. And if we do so, then we're left with negative 7/6 y. The 2/9 and the minus 2/9 cancel. And on the right-hand side, we have, negative 2/3 minus 2/9, which is the same as negative 6/9 minus 2/9, and that's negative 8/9. So we have negative 8/9. Okay, next stage would be to get closer to unwrapping the present, closer to getting to the y by itself. We will divide both sides by negative 7/6. Now, of course, when we divide by a fraction, that's equivalent to multiplying by the reciprocal. So on this other side over here, I'm actually going to multiply by negative 6/7, because this is equivalent to dividing by 7/6. Okay, a little bit of reduction in here before I multiply. Let's see, the 6 divided by 3 would be 2. 9 divided by 3 is 3. So after cancellation, it appears as though we would be left with y equals negative times negative would be positive, so we're getting an 8 times 2 on top, which is 16. And on the bottom we have 7 times 3, and that's a 21. Okay, so that's the first approach of adding, subtracting, unwrapping the present like we talked about in class. Try that on your own, pause the video and see if you want to try that on your own, and I'm going to approach this problem in a different way that I think is pretty elegant here. It takes a little bit of legwork, because instead of multiplying or adding or dividing or subtracting right off the bat by the numbers in the problem, we're actually going to multiply by the least common multiple of all of the denominators, 5, 2, and 3. And let's see, so the least common multiple of those would be not 15 but 30. I guess it would have to be 30. So then we take the equation, we multiply through by the number 30, and that's going to be multiplied on both sides of the equation, so I'm just wrapping it around the entire object. So in the first slot we would have 30 divided by 5 is 6, multiplied by 3 is 18, minus 30 divided by 2 would be 15, and then 15 times 7 would be 105, 105x equals 30 divided by 3 would be 10, and it's negative 1, so it would be negative 10. And now look, now all we have are the integers, right? We don't have to worry about the fractions any longer. So the solution process would be to subtract 18 to yield negative 105x equals negative 28, and then divide by negative 105, divide by negative 105 to yield the final answer of x equals 28 over 105. 28 over 105. Wait a second, I think 7 goes into that, doesn't it? Divide by 7. Yeah, divide by 7. 28 divided by 7 is 4, and 105 divided by 7 is 15. So the reduced answer would be 4 over 15.